In the first part of this lesson, we used um, graphs to find zeros. We can also use tables. And so this part, I'll show you how to use tables. We'll also apply some of this to real-world situations. Okay, here's a real-world example. Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by the function negative 5x squared plus 25x plus 1. And x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? So she's hitting the ball off of her tee. It's making a parabola shape, and then it's hitting the ground. When the ball lands, the height will be 0. So we're interested in finding the zeros of this function. So we're going to do that. We want negative 25x squared, negative 5x squared, sorry, plus 25x plus 1. Make sure that when you type this function into your calculator, when you do this negative sign, you're using this negative button to make that negative sign appear. Okay. When I graph this, I notice that my window isn't great because I can't see the top of my parabola, so I'm sure that it curves back around and makes a parabola shape, but my window doesn't show that. So I can hit window, and the problem is that the top of my window is cut off, so I need to make my Y max bigger. I'm going to try 50. If I'm wrong, I just have to try again. Okay, so there's a picture of the trajectory of the ball, but I don't want to know the maximum height of the ball this time. I'd like to know when it hits the ground. So we're going to do second calc, and we want the 0. We don't want the 0 over here, though. We want the 0 that's after we've hit the ball, so the other 0. We want to go to the left of where it hit the ground, and then we want to go to the right of it. So we go past the 0. Then we hit enter again instead of making a guess, and it looks like it's 5.039 seconds. So how long is the golf ball in the air? 5.0304 seconds. Okay. This is another golf ball question. I want you to take a minute, pause the video, and then try to solve this one with your calculator. Okay, here's the equation. I've typed it in, and when I graph it, I get a parabola. I'm now in a standard window. If you ever lose that standard window, you can do zoom standard. The 6th one down gives you that standard window back. Okay, so then I'm going to do a second calc. I'm going to look for the 0. I don't want the one over here. I want the one on the right. So now I'm going to hit enter because I'm to the left of the 0. I'm going to go past the 0, hit enter again, and then hit enter. And it looks like it takes 1.05 seconds for the ball. So I'm looking at the x coordinate, 1.05 seconds in the air. Okay, the other solution, the other type of solving quadratic equations, we've got the real world example, we have the solving with a graph. We can also solve using the table feature of your calculator. Just like when we're solving equations with a graph, we still want these to be equal to 0. So we're going to add to both sides of this to make sure that it's equal to 0. And when we do that, we have x squared minus 7x plus 6 equals 0. I'm going to type that into my calculator. So x squared minus 7x plus 6. Now instead of hitting the graph button, I'm going to hit the blue table button. So in a table, I'm looking for where the y coordinates are equal to 0, and it looks like in this table, it's x equals 1 and x equals 6. I can also be looking for sign changes. If I don't see a 0, but I do see a sign change, then I know the 0 happened in between those two x coordinates. These ones do have actual zeros showing. So x equals 1 and x equals 6 would be the zeros from that table. So that's a way to use a table to solve a quadratic equation. For number 2, I want to make sure to move the 6x over. So I have x squared plus 6x plus 9 equals 0, and then I'm going to graph that related function. Oops. And then I hit second table, and what I notice about this is that my function is decreasing down to x equals -3, and then increasing again. So it looks like I only have 1, 0 this time. This is the vertex of the parabola because the line of symmetry is it's showing that I've got the line of symmetry at -3 because these two values are equal and these two values are equal, and the 9 and the 9 are equal. So x equals -3 is my line of symmetry. My vertex is at -3, 0. So this particular parabola only has 1, 0 at the vertex of x equals -3. In your table of values, you can see when the y values are increasing and decreasing. So you can see, oh, I know that I'm getting bigger, 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 so there's no way I'm going to get to a 0 this direction. And then if I go down this way, I can find the 0 there. Okay, I'm just going to look at that last slide one last time just to summarize. So in words, you want to make sure that you write your quadratic equation so that it has an x squared term and it has an equal sign equal to a number. A quadratic equation can either have 1 or 2 or no solutions. The zeros of the quadratic function are the solutions to the equation. The algebraic solutions are x equals -4 and x equals -1. Graphically, what you see is you graph your function and you find where it crosses the x-axis or where it touches the x-axis if it's the vertex. In a table, you're looking for where your y-coordinates are equal to 0. All right, that's lesson 1 in chapter 9. That's the entire lesson. At this point, you can get started on homework and make sure that you ask if something doesn't make sense.